I'm back, my peoples, representing for my peoples, and this is diagonal sum, a Python exercise from Codewars. Let's do it. And it says create a function that receives a square matrix and calculates the sum of both diagonals, main and secondary. And it has a little definition of what a matrix is there. Realistically, for the programmer, a matrix is a two-dimensional list of numbers, and square matrix means that you've got a two-dimensional list that has the same number, or it has a number of elements in each sublist equal to the number of sublists. So a sublist, or a two-dimensional list that has three sublists, has three elements. I think I got that right. Crossing up here. I'm cracking up, people. Okay. So anyway, now to what we're doing. Create a function that receives a square matrix and calculates the sum of both diagonals, main and secondary. So what we got to do here is look at the diagonals, as it says, and calculate the sum of each diagonal. So yes, in a matrix, you have two diagonals. You've got this one that goes left to right down. Then you have this one that goes right to left down. And I believe the main diagonal is the one that starts on the left. And a secondary, I think, is the one that starts on the right. But it really doesn't matter which is which, because you're just adding them both together. So for this exercise, it doesn't really matter. Look it up. Okay, so yeah, just get the sum of both diagonals. So you have 1 plus 5 plus 9, which is 15. And then you have 3 plus 5 plus 7, which is also 15. And I believe that'll yield you 30. There we go. Going down here, now things are all screwy. Yeah, and it says it returns 30. So yeah, first diagonal, second diagonal, add them up. So this is going to involve two-dimensional list manipulation, and I'll see what I can do in here. It's a tall task, my friends. All right, let's get in here, work it out. Brother's going to work it out. Okay, so matrix is going to be a two-dimensional list. And I've got to kind of traverse it in a certain way. First thing I'm going to do is, if my matrix, or if the two-dimensional list, if there's no rows, then I have to return 0 because there's going to be no sum. Like if you have an empty list, then it will have no sum. Don't know a better way to say it. I guess I was searching for one, but there ain't one. But that's a thing to get out the way. So I'm going to create variables for my main diagonal and my secondary diagonal. So I'm going to add them together later on. And so I'm going to diagram out my strategy a little bit. Let's say we got this. Let's write up our little square matrix. So I'm going to diagram out my strategy of looping. So I'm going to create a loop with an I iteration variable, and that I iteration variable is going to go for the rows. It's going to go down. You know, it's going to go down from index 0 to whatever the end index is of the last row, but I is going to go down. And of course, that's going to allow me to get to two diagonals going down. What I'm going to do also is create a j variable that's going to go across. It's going to go from left to right. And that's going to allow me to get the main diagonal, like the 1, 5, and the 9, as we go down. And I'm also going to do a k variable that's going to go right to left. so that as I go down, I can get the secondary diagonal, like the 3, the 5, and the 7, because it's going right to left. So these three variables are going to allow me to get to where I need to get. Because when you think about the diagonals, it's, look at the top left. Its index combination is going to be 0, 0. Then the index combination in the middle is going to be 1, 1. And then the index combination of the bottom right is going to be 2, 2. And there should really, I guess, be commas in between these. The second numbers, these are all going to be come from the J. These are all going to be J's. And the J is going to allow it, it's going to start here at 0, then go here to 1, and then go here to 2. 0, 1, 2. And that's that. Now if we look at the other diagonal, the 3, the 5, the 7, the upper right, that index combination is going to be 0, 2. You know, row 0, column 2, 0, 1, 2. And then next it's going to be 1, 1. Of course, the 5's in the middle of all of it. And then we're going to have, on the last row, it's going to be 2, 0. And that is a 0. All of these second numbers are going to be K's. Whoops. They're going to come from the K variable. And the K variable is going to be counting, it's going to be counting from right to left. And really it's going to go in the negative direction. It's going to be going backwards because, you know, normal counting is left to right. K is going to go backwards. And I'm talking index-wise. Index-wise, left to right is positive, and index-wise, right to left is negative. Yeah. So that's a little bit about the strategy. I know it is not a complete explanation, but it'll give you a picture if you can piece it together. And now I'm going to throw this into code. Whoa, I didn't mean to get rid of all of it, but you can always rewind and check it out again. I'm now going to create my variables. I is going to be for the rows, and then, well, rows up and down. J is going to be for the it's going to be the columns left to right, and then K, and this will be a little bit different. Minus 1. It's going to be columns right to left. And see, K is going to start at the length of the matrix minus 1 because it's going to start at the end on the last index of the row and go backwards going right to left. That's what it's going to do. I'm going to do a while loop where this while loop is just going to use I to go down. While I is less than the length of the matrix, it is going to be going in the down direction. And then inside the body, I'm going to use J to go left to right, K to go right to left. First thing I'm going to do in the loop is I'm going to add to my diagonal totals, because like when you first start, you know, we're going to be at the, well, you'll see how it plays out, but at the beginning of each body, I'm going to add the current index to my diagonals, and then I'm going to move the diagonals down, really, or actually increment all the variables. I can't get it straight in my head, folks. So the secondary is going to be IK because, like I said, K is going to go right to left, backwards. And when I'm done with that, I'm going to increment I, increment J, because those are both going to be going positive down the main diagonal, and then K is going to be going backwards on that secondary diagonal. And really, once the while loop is done, you're going to add main plus secondary because that's the point of the exercise. Get the main diagonal, get the secondary diagonal, add them together, and there you go. So that would be that. And that really is it. There's no more code to do. I've done a reasonable amount of explanation. Don't know how cohesive it is, but I tried my damnedest, folks. That's all I can do. So let's put this sucker in and run it. Or it's already in, actually. I can just run it. My goodness. Okay, now looks good. It got the greens. All right, green light says go. That is excellent, excellent, folks. Got it good. So there is the diagonal sum. Yeah, done in Python. Yeah, 11 is for the main diagonal, or line 11 is for the main diagonal, line 12 is for the secondary diagonal, and you increment for the main diagonal row-wise, decrement for the secondary diagonal because the horizontally you're going to be going backwards through it, and you guys give it a try. Good luck. Maybe you can do it in one line. I know some people out there can, but I did it in however many lines I did. 16? And that's it. So that's good for me. I'm good. You're good. And I am out. See ya.